Hello, everybody. Welcome to Landmark Technologies. Today, we are going to be achieving a project. So we are going to be integrating Jenkins with GitHub, Maven, SonarQube, Nexus, Docker Hub, and our Kubernetes cluster. So what actually are we trying to achieve? Very important. So we are trying to achieve an application deployment. So in this application deployment, we are going to be doing what we call Jenkins, Docker, Kubernetes integration. That's what we are going to be achieving in this project. So let's just look at a pictorial representation of how our project is going to look like. So we have this project. Now we are supporting a banking client. And as DevOps engineer, we are going to be deploying an application for this banking client. So let's see how we are going to achieve this. Now, in this deployment, we are going to have developers, writing and committing code into our source code management. And in this case, our source code management is going to be in GitHub. So we have GitHub. This is GitHub here. So when developers write the code, once they are done with their development, they'll commit this code into GitHub. So they commit the code into GitHub. And remember, when developers are committing this code into GitHub, before they do that, they must have performed unit test cases. That is, the requirement for this project, and that's best practice. So code are written and developed in GitHub, and we are going to have the source code plus the build script plus test cases. Think about that. Test cases. Now, this is what developers are committing into GitHub. Test code, build script, okay, and our source code. All of this is committed into GitHub. So here we have, our repository, our Git repository. So these are a Git repository. Now, once this is committed into GitHub, what happens is that we are going to be using a CI/CD tool, okay, which in this case, we are going to use Jenkins. So Jenkins is going to be our CI/CD tool for this project. So we are going to have Jenkins. Let me change this image or use this for Jenkins. We are going to have Jenkins. This is Jenkins. So now, what is going to be achieved in Jenkins? What happened is that immediately the code is committed into GitHub. This is Jenkins. So Jenkins is going to pull the code from GitHub. Now, once Jenkins pull this code, so what is happening is that in Jenkins, we are going to have a CI/CD job. You see that? We have a CI/CD job. And in this job, what is happening? It's a pipeline job. In this job, in the first stage, Jenkins is going to clone the code. Therefore, as the code is committed to GitHub, Jenkins will clone the code using the Git plugin. So it's going to be Git clone. So in Jenkins server, we are installing, okay, Git. Now, what else is Jenkins going to do? Jenkins is going to execute MVN, Maven build. So Jenkins will be executing Maven build. So Jenkins will use Maven to do a build. Therefore, in the Jenkins server, we are going to be installing Maven as a plugin or as a global tool configuration. Now, what is going to happen next? Once Jenkins does the build, remember, the build goal is going to be NVM. So we have NVM package. Now, in this NVM package goal, testing is going to be performed. That is code validation, compilation, testing, and the artifacts are going to be created. And this project is going to be a Java-based project. So now what happens is that when developers commit this code in GitHub, Jenkins is going to pull this code. So the code is going to be pulled by Jenkins or clone via the git clone, command option. So Jenkins clone the code. Once Jenkins clone the code, it performs NVM package. Now, after a package is created, the next thing Jenkins is going to do is that Jenkins is going to integrate with SonarQube. So now, with SonarQube, what is Jenkins doing with SonarQube? With SonarQube, let's have SonarQube somewhere here. So now, once this package is created, we have SonarQube. So Jenkins is going to be carrying out one more, code validation, like to check code quality. Does it meet everything that we wanted? You see that, therefore, Jenkins integrate with SonarQube for code quality. So here with SonarQube, Jenkins is going to be executing code quality report. So the purpose of this integration is for code quality. Take note about that, very important. Now, so code quality report is going to be executed here. Now, once the artifacts are created, if everything is okay from the code quality report, the next thing Jenkins is going to do is that now Jenkins will upload this artifact into our artifact repository in Nexus. So here we have Nexus. And what happens with Nexus? In Nexus, artifacts are going to be uploaded. So we have Nexus. Now this is Nexus. In Nexus, artifacts, we upload what? We upload artifacts. Take note about that. So in Jenkins, artifacts are uploaded now. So Jenkins will upload the build artifacts that Marvin had created into Nexus. So we have this integration between Jenkins, and Nexus now. And for that to happen, Jenkins is going to be executing. Here we have for SonarQube integration, we are going to be doing Sonar, NVM, Sonar. Now, once this package is created, we have our package created. The next thing that we are going to do after this package is created, and it is uploaded into Nexus is that now our project, we are going to be using the Docker file. The purpose of that Docker file is to achieve one thing. Now, once this artifact is created, we want to deploy our artifacts, using Docker containers. As such, we are going to use a Docker file to build a Docker image. So we are going to build a Docker image from the artifacts, and take note that the files that are created here, they are going to be generally Java packages. Why? Because our code, is written in Java. So it's going to be a jar file, either jar, wa, or ER files. So this is what is going to happen. So these packages that are created, this artifact that are created, Jenkins is going to use those artifacts to create a Docker image. So inside Jenkins, we are going to install Docker, and as such, we'll be doing Docker build. So with the Docker build command, what are we achieving? We are creating a Docker image from the application that has been created from the NVM package command. Now, which therefore implies in our Jenkins server, what are we going to do in the Jenkins server? In the Jenkins server, we are going to install Docker, okay, and we are going to add Jenkins user to the Docker group. So please, it's very important. Now, once this Docker image has been created, the next thing we are going to do is that now, part of our Jenkins job is we are going to do Docker push image. So we are going to push this image into Docker Hub. Now, after we push this image to Docker Hub, okay, the next stage, what we are going to be doing next is we are going to remove the image from our Jenkins server with a Docker remove image command. So we are going to remove the image. So the image wouldn't be on our local Jenkins server anymore. The image is now in Docker Hub. So now in this push, we are going to have Docker Hub. Okay, we have Docker Hub. Therefore, our image is being pushed in Docker Hub. So whatever image that is created, we are going to push it here into Docker Hub. So please take note, very important. So we have Docker Hub, where we are going to push our image. So we have Docker Hub. We are going to push the image created in Docker Hub. So our image is going to be found in Docker Hub. So please take note, this is a very important stage, and this is achieved by Docker push command. Take note about that, Docker push. So we are going to push the image created from our application in Docker Hub. Now, once this stage is accomplished, the next thing is that we are going to now deploy these into a Kubernetes cluster. Therefore, the image that has been created, we are going to use Kubernetes to orchestrate our Docker containers, meaning that our applications will be running, okay, as Docker containers in our Kubernetes cluster. Now, for that to happen again, what we are going to do is that we are going to have a Kubernetes cluster of this. So we have a cluster, something like this. Here is going to be our cluster. So in our cluster, okay, we are going to have both worker and master nodes. So we have nodes like this in our cluster. We have the master, which is equally the control plane. Now we have the master. We also have some worker nodes. You see that? So we have master and we have worker nodes. Let me come. Okay, we have master and worker nodes, something like that. So in our cluster, we are going to have our master node. So we have master and worker nodes. Take note about that. This is master. This is worker node. So master and worker. So this is our Kubernetes cluster. So now in this cluster, what else are we going to do? In the Jenkins server, we are going to equally install, we are going to install in the Jenkins server, we are going to install kubectl. Therefore, in the Jenkins server, we are going to be executing kubectl apply. Now, once we execute kubectl apply, what happens is that our applications will be deployed in this Kubernetes cluster. Therefore, this is where deployment is going to take place. So deployment is going to take place in our Kubernetes cluster. You see that? So how are we going to achieve that? So here we have application deployment. So we are going to be doing deployment. Okay. So in our cluster, we are going to be deploying our applications with the kubectl apply command. You see that now, and remember that how are these applications are okay running. So here we have deploy applications, deploy applications, apps, as Docker containers. You see that? So please take note about that, very important. So we are going to be deploying our application as Docker containers in this Kubernetes cluster. Now, for this deployment to take place, we are going to execute the command kubectl apply command in our Jenkins server. Once this command is executed, what happens next is that kubectl, Kubernetes is going to pull our image. You see that? Therefore, the image that was created, and pushed to Docker Hub, Kubernetes will pull that image to deploy our application. So we are going to have something like this. Kubernetes will pull the image. You see that? It will pull the image from Docker Hub. This is where it's going to pull the image. And once it pulls this image, what happens is that it is going to be creating. So we are going to have pull. So our image is going to be pulled from, Docker Hub. You see that? Kubernetes will pull this image from Docker Hub. Now, once our image is pull image. Now, once they pull this image, what happens next is that, look at something, please. It pulls the image and deploys the application. Now, after this application is deployed, it's going to create port on our worker node. So we are going to have ports are going to be created where our applications will be running. So in this case, we are going to be deploying a Spring Web application. So it's going to create port. So we are going to have port like that. So we have port. So port are going to be created. You see. So now, this is what we are going to have. We have our worker and our master node. The next thing is, once this application is deployed, we are going to see how this application that is running in our Kubernetes cluster can be accessed. How will end users access this application? So one more thing is that we are going to configure a Kubernetes cluster, and this is how it's going to look like. Kubernetes cluster with one master and two worker. Now, for end users to access this application, for end user traffic, so we have end users, for end users traffic to talk to our application, this is what is going to happen. So we are going to have, we will need to create a service, because for you to allow external traffic into your application, you need to create a service. And the service type we are going to create in this example, we are going to be creating a load balancer service. So now, inside our cluster, we are going to create a service inside this cluster. So we have service created, load balancer. So we have load balancer service created. So we are going to have load balancer service created. Therefore, now end user traffic will not be allowed, to get directly to this cluster. So what happens is that end user traffic will be routed to this load balancer in our cluster. Once it gets to the load balancer, the load balancer will now talk to the port, the application, because in this port, we have our applications running. So end user traffic will talk to this port. So it's going to be in this order. So we have end user traffic. So now the load balancer can route traffic to all the ports that our application is running. So please take note, it's very important. So we are going to have something like this. So we have our application port. This is our app port, our application port. Now we can have multiple replicas. Now, as part of this deployment, we will equally be deploying a database, MongoDB database, and that database will equally be deployed as a Docker container. So what happens is that we'll deploy a database as well. So we are going to have our MongoDB port. So this is going to be our database that is going to be equally deployed as a port. And for this database that we are deploying, for this database is going to make use of a service type. And that service type is going to be cluster IP. So we are going to have a cluster IP service for our database. Why? Because our database can only be accessed, okay, or should only be accessed internally within our cluster, because databases are highly critical application. So we have cluster IP service, That's what we have. Therefore, now when traffic get to our external traffic that is from our end users, okay, traffic is going to get to this load balancer. Once it comes to the load balancer will route the traffic to the port where the applications are running. So this is what is going to happen. Once it talks to our application will equally talk to our MongoDB database using, okay, the MongoDB service. So we have a Mongo service, okay? We have a Mongo service. This is a Mongo service. Now, in our application here as well, Spring App, we equally have a Spring App service, Spring App. So we have a Mongo service, and we also have a Spring App service, something like that. So these are the services that we have. So once traffic comes to our external traffic comes to the load balancer routes the traffic to the port, okay, where our applications are running. You see that, what would the port do? The port will equally route the traffic. Let me just display this stuff to just make it look a little bit glaring. Let me display this guy. So we have our port here. We have our port. Let me come here. So we have our MongoDB database, and we have our application. Is our application port running, Spring App. So now traffic comes to this application port, okay, and as well, our load balancer will be routing traffic using an algorithm to all the to all the port. So now, once traffic gets to this port, what happens is that, let me just, once traffic gets to this port, okay, once traffic gets to this port, now, our application port is going to talk to our database using the database service. That's why service discovery is very important in Kubernetes. So we are going to have something like this. Now, our application port, you see that, talk to the, now, our application talks to the database via the database service, okay, and the service now talk now to our database in this order. So this is how communication is going to be established. So what we are going to do next is that we'll try to set up this entire infrastructure, okay, we'll set it up and see how we are going to be able to achieve full automation with what you see here. This is equally what we call a multi-tier, okay, application deployment. This is equally a multi-tier application deployment. So now, what we'll do next is that we are going to create a server in AWS Cloud. So let's create our server in AWS Cloud. Let me come here. So now, Jenkins Docker Kubernetes integration. The first thing, we are going to install and configure Docker on Ubuntu any Ubuntu server. But in this example, we are going to use AWS. So we are going to be installing our Docker server in AWS Cloud. So let's see how we can easily achieve that. Docker in AWS. So I'm logging into my AWS account now. Log into my AWS account. Okay. This guy that is running. Now, I'm going to install a Jenkins server or install a new Jenkins server. I'm going to go for Jenkins, the Ubuntu, or choose Ubuntu 18.04 version. Now, I'll equally go for the T2 medium. Okay, T2 medium, because I need, it's going to give me 2-core vCPU and 4 gig of RAM. So the next stuff is storage. I'll allow storage by default. Now I'm going to assign a name. I'll call this server Jenkins admin. That'll be my Jenkins admin server. So now I'm installing this server environment. The environment where this project is carried out is on production environment. So environment here is production. Just adding tag to the server. That's my environment. Configure security group. Now, I will just create a new security group. I'll create a new security group and I'll just call it production SG security group. So I'll call it production security group. And for now, since I'm going to be installing Jenkins, I need port 8080 open. So I'm going to add the port here, port 8080 open from anywhere. Now, I'll equally, okay, so this is the port that I need. Okay, this port will be open from, okay, anywhere. So I have that running. So let me launch my cluster. It's asking for a key. I already have a key called new. I'm launching this Kubernetes, Ubuntu server called Jenkins admin. So it's going to take like 2-3 minutes to get ready. Now, once this is ready, I'll connect to it. And this is what I'm going to be installing. I'm going to install and configure Docker. So I'll execute this as a script. Okay. Sudo apt install Docker. It will install Docker. I'm going to start Docker as well. Okay. Sudo system. Let me see. Systemctl. Sudo systemctl start Docker. Sudo systemctl. So I'm going to start and enable Docker with this command. Now, the next thing I'm going to do is I'm going to install and start and configure Jenkins. I will install, start, and configure Jenkins. Okay, so I'll equally add the Jenkins key, download the Jenkins packages, and I'm going to install Jenkins. So in the same server, okay, in our Jenkins server, I'm installing Docker as well. You see that now, once I install Jenkins, I'm going to start Jenkins, sudo systemctl start Jenkins. Okay, I'm going to start Jenkins. Now, once I start Jenkins, the next thing I'm going to do is that I'm going to add Jenkins user to the Docker group. And the question is, why do I need Jenkins user in the Docker group? Now, I need Jenkins user in the Docker group because I want Jenkins to be able to execute Docker commands. So I'm going to add Jenkins user in the Docker group because we need to create, okay, our Docker image. And we are going to be creating the Docker image as Jenkins user. Once I add Jenkins user to the Docker group, I will just, restart Docker, system CTL, restart Docker, restart Docker. And one other thing I'm going to do is that I'm going to be adding Jenkins user to the sudoers group, so that Jenkins can perform some admin tasks. So this is the first, configuration we are going to do. So let's find out if our Jenkins server is up and running now. It should be up and running. Let's connect to it. Okay, now our Jenkins server is up and running. I'll connect to it using an SSH client, MobileXterm. Let me connect to my server using MobileXterm, SSH client. Connect to it using SSH client, MobileXterm. Okay. My server is Ubuntu, so the default user will be Ubuntu user. Let me attach my key. I'm going to access my server using my key, the key of the server. So I'm trying to access the server for the first time. Detach tab. So now I am in this server. I am in this server. So let's see what we can do to get this configuration done with. So I'm in my server. Now, the first thing I want to do here, I'm going to be installing Docker, and I'll install and configure Docker. I'll also install and configure Jenkins. Now, for me to be able to install and configure Jenkins, I will equally need to ensure that I have Java installed, because we need Java to be installed. Okay, so the first set of installation we are going to do here, let's see how we are going to install Docker. So if I execute this command, you should get Docker installed. I can execute all these 3 commands at once. App install, so I'll just copy these 3 commands and execute them. Docker will be installed. Let me see. Fail to install Docker. Let me see something here. Let me do Docker. Okay, can't install Docker, but gives me the option. Let me just execute this command. Sudo app install docker.io. Building dependencies. What is happening here? I don't know. I got some errors. Let me try to rerun that sudo app install. Let me first of all do sudo. Let me do sudo apt updates. Let's update the packages before installing and see if we get what we needed. Let's install the package. Let's update our packages and install Docker. So install packages, sudo apt install, sudo. Okay. Now we're installing Docker. So make sure you update your packages before installing Docker. So we are going to do here sudo. Okay, so we do sudo apt update. We update our packages -y before installing Docker. So now we have Docker installed in this server. So let's start Docker systemctl. Let's start and enable Docker. So with this command, we are going to start. So Docker have started and Docker is enabled. Now, the next, we are going to install and configure Jenkins. So before doing that, the first package to install Jenkins needs Java as a prerequisite. So first of all, we are installing Java JDK 11, Java development kit, installing Java. Once Java is fully installed, we equally just install Jenkins. So I'll just copy all this command. It will install and start Jenkins. So all of this is going to install and start Jenkins. Let me get Java fully installed. So our main, our main purpose for this project is to see how we can integrate Jenkins with Docker and Kubernetes for application deployment. Okay, Java is installed now. We can do Java -version. Okay, we have Java runtime 11 and Java JDK 11 installed. So let's install. Okay, we are now installing Jenkins. We're installing Jenkins. So we have Jenkins. Let me see the commands that we executed already. Make sure that we had all the commands executed. Clear. Sudo. App install Jenkins. Let's get Jenkins -version. Jenkins -version. Okay, let's start and let's enable Jenkins. Let's enable Jenkins. Okay, want to enable Jenkins. Okay, let me make sure Jenkins is enabled. Systemctl start Jenkins. I'm going to start Jenkins now. Start Jenkins. Oh, fails to start the Jenkins service. Let me try to troubleshoot what could be the problem. Systemctl start Jenkins. Fails to start Jenkins service. See what happens. Sudo app update. Sudo app install Jenkins. Let me try to see what is the error message that we get. Trying to install Jenkins after the operation. Yes. Jenkins. Setting up the Jenkins daemon. Okay. So let's try to start Jenkins now. Systemctl start Jenkins. Okay. Jenkins has been installed. Jenkins, we have installed and started Jenkins. The next thing we are going to do is we are going to add Jenkins user. We are going to add Jenkins user to the Docker group so that Jenkins can execute commands. So we'll add Jenkins user to the Docker group and we start Docker. So Jenkins sudo user mode. So we have added Jenkins user to the Docker group. Okay, we have restarted Docker. Now, one more thing we are going to do is we are going to add Jenkins user to the sudoers group. So with this command, we are adding Jenkins user to the sudoers class. So now Jenkins has been added, okay, to the, okay, sudoers group. So one more thing, let us check Jenkins shell. I'm going to VI, or do sudo VI, etc password. Now Jenkins got a shell bin bash. So we can now become Jenkins. We can become Jenkins, sudo su Jenkins. Now, we are now the Jenkins user. Very important. So Jenkins is now in the sudoers group, and as such, Jenkins can execute sudo command. So let's see, what have we achieved so far? So far, we have configured Jenkins and we have configured Docker. Those are the two things we have done. The next thing we want to do is, since, for example, now that Jenkins is in the Docker group, Jenkins can execute Docker command like Docker PS. You see that Jenkins is able to execute that. So, but let's see how to access Jenkins on our browser. Okay, but before we do that, I want us to, install kubectl. Now, we are going to install kubectl on this Jenkins, server. We'll install kubectl, and we are going to configure our Kubernetes cluster using kops. So, as you can see, attaching require configure Kubernetes cluster using kops in AWS. Now, kops is going to permit us to configure a production-grade Kubernetes cluster. So I'm going to VI, I'll do kops install kops.sh. Now, I want to create a script. That script, I expect that script, to install a Kubernetes cluster using kops. So for that to happen, I'll first of all install AWS command line interface, CLI. So now, this is going to install AWS CLI for us. So that's installing AWS CLI. Now, once that is installed, I'm going to equally install the kops software. You see that? So equally install the kops software with this command. App install kops. So the kops software will be installed on my server. So that's the next thing I'm going to be doing. So I'm creating a bash shell script to achieve this installation. Now, once kops software is installed, the next thing I want to install after installing kops software, I'm going to install kubectl. So kubectl is the command line utility for Kubernetes. So I'm installing kubectl. So that's what I'm installing next. Install kubectl. Now, after I install kubectl, I'm going to create an S3 bucket. So I'll be attaching an IAM role so that I can create an S3 bucket, because kops is going to need S3 bucket the etcd store and to store other Kubernetes secrets. So let me first of all install kubectl. I'm installing kubectl, I'm installing kops and AWS CLI. Now, before installing AWS CLI, if I execute the command AWS is not installed. But with this command, with this script, I'll be able to install all of that. So I'll just do sh kops. Now it's installing, for me, AWS CLI, kops software, and kubectl. So let me have those installed. And AWS CLI need Python. So it's also installing Python. AWS is on Python. And it is important for you to take note at this point that when you are trying to provision resources on AWS, you can either do that directly from the console or from the command line. So we have installed AWS CLI. So if I do AWS now, I can do AWS S3 LS. Now, I am unable to communicate because I have not yet attached any IAM rule to this, EC2 instance, to this my Jenkins server. So what I'm going to do next is that I'm going to create an IAM rule from AWS console, and I'll attach these policies to it. So let us go to the AWS console and see how we can achieve that. So in my AWS console, I have this server running, which is called Jenkins admin server. I'll click on that server, and I'm going to come here under security. Okay, no, let me, action, come here to action, click on security, modify IAM role. Now, I can just add the admin role. This admin role can execute anything that I want. So if I add the admin role to this server, okay, if I add the admin role to this server, I'm attaching an IAM role to my EC2 Ubuntu instance where I've installed Jenkins. So if I attach this role to this server, now that is the admin role. It means it can execute any command in my AWS account. You see that? When I executed this before AWS S3 LS, I was told you cannot configure credentials. Okay, why? Because no credentials could be located. So now I have my credentials. So the next thing I'm going to do is I'm going to create an S3 bucket, which I'm going to use in my corpse configuration. So let us make bucket, S3 make bucket. I want to create a bucket for this purpose. I'll call that bucket my landmark tech.local, my landmark tech 23.local. That is the bucket I'm going to create in my AWS account, S3 bucket. So AWS, so the command is AWS S3 MB means make bucket, okay, and that is the bucket name. And take note, this bucket name must be unique across all AWS accounts, which means no two S3 bucket names can exist in AWS. So if I do enter, so that bucket name is created. So since this bucket name is created, the next thing I'm going to do is I'll define environmental variables. So let me define my environmental variables. So via into .bash rc. Now, in this .bash rc, I have created an S3 bucket. So I'm going to export that information. You see that? I will export that information. Let me show you. And I'll equally create my Kubernetes cluster. And I'm going to call that cluster my landmark tech.k8s.local. So that is the cluster I'm creating. Okay. And this is the bucket I created. I created this bucket. This is my bucket. So I'm going to export this information in, okay, .bash rc file. So these are my environmental variables. These are my environmental variables. So I want to create a cluster, and my cluster name will be called, okay, my landmark tech.k8s.local. So this is my Kubernetes cluster name, my landmark tech.k8s.local. And the S3 bucket where my key value store is going to be like my etcd and all other certificate information, okay, my log files is going to be in this S3 bucket. So configured. So now I'll also ensure that I refresh source.bash rc, enter. Therefore, if I execute echo, if I do echo $name, what do I have? This is the name of my cluster. So now that I've done this aspect of it, I'm going to create a key, because after configuring my cluster, I need to be able to access that cluster. So I will create an SSH key and copy the key into this cluster I'm creating, so such that I can be able to access this cluster, okay, from my Jenkins server. Enter. Okay, key is created. So now that my key is created, I'm going to configure my cluster now. So I want to create a cluster, and I'm going to create that cluster. Let me check where my, I'm not now in Oregon, US West 2. I'll create this cluster in US West 2A. So let me come back here. I want to do it in US West 2A. Okay, so this is the cluster. So I'm going to execute this command, kubectl create cluster, master node is 1. Okay, now for the worker node, so let me execute the command as well, kubectl create cluster. Now, this is a cluster which I want to create. I'll use T2 medium, T2 medium for my worker node. So kubectl corps create cluster. So with this command, corps create cluster is going to create a cluster in US West 2A availability zone. And we'll be creating my networking as well. Okay, networking, the weave network. And let me just show you all of that information. You see that it's going to create networking weave network. It's creating master node, the count is 1. It's creating worker node, the count is 2. And it's creating it in the name that we had defined as environmental variable. So that is what we are achieving next. So let me execute that command. So it's trying to validate. Okay, so my cluster is going to be created. So if I run this command, corps get cluster, you see that this is the cluster that will be, okay, provision for me in AWS account. So corps is so powerful because corps is going to create this cluster with some other resources. As a matter of fact, it creates an entire infrastructure, as you can see here. You see that corps is going to create all of this infrastructure. It's going to be creating a VPC. It will be creating, auto scaling group, subnet, private and public. It creates everything for us. So let us now copy our secret into this cluster. You see that we are going to copy the secret file. Okay, kubectl. Let's copy the public key that we created into our cluster such that we can communicate with it. Enter. Oh, let me see something. Did I copy everything? Let me make sure that I got it correctly. So corps, I think I missed out the key. Corps, create secret. Okay, our secret is created. Now we can validate our cluster. So we just do corps, validate, corps, validate cluster, corps, validate cluster. Now the name is $name. Remember, we already know the name. Okay, $name -- yes. Corps validate cluster. Oh, let me see. Did I execute the command correctly? Let me just copy and paste. Corps validate, corps update cluster rather. Corps update cluster. Now, with this command, it's going to create our cluster. Corps update cluster. It's going to create the cluster for us. It's going to create the cluster for us. Kubernetes cluster is being created. It will take about 5 to 10 minutes. Now, we are told to wait for 10 minutes. So in 10 minutes time, this cluster will be fully provisioned. And it has given us some other options. So I'll copy these suggested commands, which have been given. After 10 minutes, I can execute those commands to know what is happening. So I have these suggested commands. So we have validated our cluster. Okay, we have updated. So it's creating the cluster and it has given me some suggested commands to execute. Now, why this cluster is being provisioned, because it's going to take a while. The next thing I want us to do, let us try to access our Kubernetes server for the first time. Okay, our Jenkins server. Remember that we have configured Jenkins. So let's get into this Jenkins server. These are Jenkins server. We had opened the required port, which is port 8080. So I have here 8080 to access my cluster, my Kubernetes. So this is my Jenkins server. So I can access my Jenkins server. It's requesting for a password. So let me copy this password. Requesting for a password. I have to cut this information. Let me cut. The password is a secret. Cut. So as Jenkins user, okay, that is my admin password. So I enter the password here and log into my Jenkins server for the first time. Now, once I log into this server, for you to use Jenkins to integrate Jenkins with other tools to achieve automation, you have to install some plugins. So it is giving me some suggested plugins to install. Let me install suggested plugins. Okay, so it's getting started. It's going to install those plugins for us. All the suggested plugins that I need is being installed. It's being installed. Like we have cluster rule binding. All the suggested plugins that we need is being installed for us in this server now. So it could take a few minutes to get all those plugins installed. It's taking a few minutes. You see that all the required plugins that we need, is going to install those plugins for us. So now it wants me to create my user's credentials. I'll create that. Username, Landmark Technologies, password, enter my password confirm, full name, Landmark Technologies, email. So I'm validating all this information, save, validated. So my Jenkins server is ready. This is my Jenkins server. In this Jenkins server, we are going to create a pipeline project. So I'll click here on new item. Under new item, okay, we are going to have a pipeline project called Spring Java app. This is Java web application. Spring Java web app. It's a Java web application, okay, that needs a database, Mongo. So this is our project. Now we are creating a pipeline project. Remember, you can equally create a freestyle, but in this case, we are going to be creating a pipeline project. So I'll click here, pipeline, Spring Java Web App Mongo. I choose OK. Now, this is my pipeline project. So in this pipeline project, we want to create a pipeline job. Remember, as we saw here in the diagram, when developers commit their code to GitHub, what happens? Jenkins is going to pull that code. Okay, so how is Jenkins pulling the code? Okay, like git clone, you see that? Jenkins is pulling the code. This is what is happening. So now we are creating a pipeline project. So the first stage of that project is going to be for Jenkins to pull this code, okay, from GitHub. So let's see how to achieve that. So this is our pipeline project called Spring Java Web App Mongo. So now I'm going to click here on pipeline. It takes me below here. On this pipeline, we are going to create a pipeline project. So let me just show you how that pipeline script will look like. So we are going to create a pipeline script, Jenkins file. Oh, let me see. Yep, Jenkins file. We'll create a pipeline script, something like this. So now we want to create a pipeline script. Let's create a pipeline script. So in this pipeline script, okay, we are going to be referring to our node. So we have a Jenkins server, which is referred to as node. So now everything is going to be inside this node. You see that? So we are going to define this first stage, the first stage, which is, okay, we have stage. In the first stage, we want to clone our code from GitHub. So we'll just call it SCM, okay, clone. So we are cloning our code from GitHub. So now, once we do that, okay, we have something like this. So whenever there is a stage, we have this bracket, okay, this curly bracket. So this is these are Groovy script. Here's our Jenkins file. So now, this is the first stage. We want to clone the code from GitHub. So how do we clone the code? Normally, we can do git clone. Git clone, you see that? But this is not what we are going to actually do. We are going to go, let's go back to our Jenkins job. Now, in this Jenkins job, we are going to choose, okay, look at something, we'll choose pipeline syntax. So I'll go to pipeline syntax. In this pipeline syntax, once I clicked on it, it brings me to this page. I'm looking for Git, okay? I'm looking for Git. Now in this Git, I did my project repository. Now, this is my project repository, Spring Boot Docker. This is my project repository. So let me come here, project repository. Now, this is my project repository. So it wants me to enter that information for this in the pipeline. It asks for the repository URL. I've entered my repository URL. Where is the code found? In the master branch. Do I need any credentials? Yes, I do, because this is a private repository. Therefore, I'll click on under credentials, I'll choose add, okay, credentials. And what I'm going to add here is going to be my username and password. My username is Lega2045. I'll enter my password as well. Now, I've entered my password, and I'm going to call this GitHub credentials. Git, okay, hub credentials. That's what I'm going to call it. This is my GitHub credentials. Okay, the same thing under description, I'll call it GitHub credentials. So that's my GitHub credentials. Now I'm creating this, created. You see that? This is my GitHub credentials. So in these credentials now, I'm going to, under credentials, I'll choose GitHub credentials. You see that? This is what I'm going to choose, GitHub credentials. And I'll generate my pipeline syntax, generate pipeline script. This is the pipeline script. You see that? So I come back to my Jenkins job. In my Jenkins job, where you see git clone, that's not what I'm going to use. I'll use this pipeline syntax, which I have here. You see that? Therefore, this is the end of stage one of my project. So with this now, I can clone my code from GitHub. So I'll copy all of this, copy this script, go to my Jenkins job. Let me delete any other thing that can. So I'm deleting this. Okay. So in this Jenkins job, I'll just paste this script that we have created, paste in the script. Now, this is my script in my Jenkins job. You see that this is my script. Let me apply. Everything is okay. So it's going to clone the code from GitHub. You see that? It will clone the code, save. Now I can click on build now. So I click on build now. See that? It's trying to, so it has cloned the code. Now, therefore, Jenkins has cloned the code, okay, from GitHub. All the source code that developers commit to GitHub have been cloned by Jenkins. The next thing is that we want to execute NVM clean package. You see that? Now we need Maven. So we are going to install Maven in our Jenkins server. So we'll go back to Jenkins. In the Jenkins server, I'll click on the dashboard, go to Manage Jenkins. In Manage Jenkins, we'll go to Global Tool Configuration. Now, in the Global Tool Configuration, we are going to be searching for Maven. So you click on Add Maven. Now, we are going to add Maven. Let's call it Maven 3.6.3. So this is the Maven version that we are going to install. You see that? Maven, that's the version. You can choose any version that you want, but we'll go for Maven 3.6.3. We now save. Now, as we save this, this step, let's go back to our pipeline script. Now, in this pipeline script, we have the next stage. This next stage, the next stage is Maven build. So we want to use Maven to do a build. So we are going to call this stage Maven build. So now, in using Maven to do a build, the command that we are going to use, so we are going, since this is a Linux box, we have sh, now the command that we normally use to do a build is nvm clean package. nvm clean package. This is the command. But if we execute this command at this stage, we are going to have, the command will not be executed. Why? Because it will not be able to identify the path of Maven. So what we are going to do is that we are going to use some Groovy script syntax to define Maven path. So we'll define it as a function. Maven home. Where is our Maven home located? Now, we had configured Maven home as a tool under global tool configuration. So we'll put here tool. And what is the name of the tool that we have used? Tool name. The name of the tool that we configured, we call it Maven 3.6.3. Please take note. So we are defining this as a function here. You see that? We are defining a function that now when we are trying to do nvm clean package, that command will be executed in the Maven home. Reason being that now the Maven command, this nvm, this script that execute the Maven goal is found in the Maven home directory in the bin directory. Therefore, how are we going to call this Maven home? How do we call it? We'll now call it as a variable, something like this. Call it as a variable. You see that? Now is Maven home. So we are calling this as a variable. So Maven home, which is under 2, is called as a variable. And in Maven home, what are we searching for? We are searching for bin. You see that? And inside bin, we have nvm. So with this command, we are able to do a build with Maven. nvm Maven home directory. In the bin directory, there is a script called nvm clean package. So that is a stage. So this stage is going to create our package for us. Now, the next stage, after, if this package is created, we are going to introduce one more stage, and that stage is called, SonarQube report or code quality. You see that? We can call it quality report to find out, if our code meet the quality threshold. And similarly, you have to open this Ginger bracket, and we are going to execute a similar command like this, similar command, but not nvm clean package in this case. As we know, for you to execute a command, for SonarQube, to execute SonarQube report will be sonar. Now, this sonar, the first sonar is the goal. Okay, we have the goal. You see that? And the objective. So with these artifacts that have been built from our code clone, code quality report will be prepared. And if everything is okay, the next stage, we are going to upload that. We'll upload it. Okay. Nexus. Upload. So we are going to upload the artifacts into Nexus. Okay. We'll upload the artifacts into Nexus. And how do we do that? Remember, this is going to back up whatever artifact that Marvin created here. Now, we want to back it up in Nexus such that, because Nexus is the remote repository for Marvin, such that if something went wrong with our Marvin server, we will still have the artifacts in Nexus. So we are going to execute this same command, nvm. Okay, we're executing nvm. In this case, it will be nvm deploy. It's nvm deploy. So let's execute these 3 stages and see what we get. So I'll just copy these 3 stages. But now, since we have not done any configuration for SonarQube, I'll just put a comment here. We'll put a comment, okay? Put a comment there on Nexus. So, but it's good you know that that stage is included in the pipeline project. So now we come to our Jenkins dashboard, click on the job, go to configure, click on pipeline. Okay, let's add the additional steps. So we have NVN clean package. We expect that to be executed. Okay, everything is fine. Last line, there's a problem there. Let me apply again. Okay, everything is okay, saved. I'm going to click on build now. I'm going to click on build now. NVM, something is wrong. What am I to? Workspace not found / bin not found. What could be the problem? Clean package. Let's go back there and see what is the problem. We are told here that NVM clean package. This workspace / bin. It's not found. Let's troubleshoot. Let's go back. Let me see what is the problem there. SH NVN clean package. Why is this stuff not executing? Let me see something here. NVN. This is our Marvin home. To name. Where is the problem? Okay, it seems I'm missing out on the function of here. So I'm missing out on the function. I'm not calling the function. So let me call the function. This line is missing in our script, so it cannot be executed. It's missing. So let me add it there. Okay, so the function was not defined. So let's save now. Build. We are doing a build. Console output. You see that? Wait a minute. What are we told again? NVM not found. Let me make sure that we have /bin. NVM not found. NVM not found. Let me see something. NVM not found. Let me go back to global tool configuration and find out, make sure that everything was configured accordingly. Global tool configuration. Did I configure Maven 3.6.3. Yep, that's Maven there. That's a version saved. Telling me that dashboard. Console output. Maven. Let me go back to configure projects, make sure that pipeline script is configured accordingly. SH. SH. Maven build. This is Maven home. That's it defined here. /bin /nvm clean package. Where is it? Clean package go not executing? Let me see. Okay, let's try to check it out. Let me do a build again and see what we get. Okay, let's try to check it out and see. Okay, so let's just try to see how to get done with this project. So what we are doing here is that, again, we are trying to deploy our application into, a Kubernetes cluster. And now this is a pipeline job that we have written. In the pipeline job, in the first stage, we are cloning the code from GitHub. Jenkins is pulling the code. Now Jenkins is doing a build, okay, with NVM package go, clean package go. That's what Jenkins is doing. Next, Jenkins will execute SonarQube report, upload the artifacts into Nexus. Okay. Now, once the artifacts are uploaded, the next thing that is going to be done is that now, since we have installed Docker in Jenkins, we are going to be using Docker. Okay, we are going to execute the Docker build command now with the help of a Docker file. So let's go back to our project and see how the Docker file for this project looks like. So we have, let me come here. Let's get to our Docker file. So let's save this guy. Docker file, MongoDB. MongoDB. Spring App, MongoDB. Let me see something here. Okay, we have our Docker file. So if you look at this project, it has a Docker file. And this is how the Docker file is. It's going to download the base image, which is OpenJDK, Java Development Kit version 8, okay, on Alpine. And the next thing is that, it's creating an environment with some run command. It's going to update, it's going to create, add this this shell, okay, bin sh, the Bourne shell. And the next thing is with some run command, But what is very important here is that any artifact that is going to be created, this jar file will be copied and deployed in this application. Therefore, when we deploy our containers, okay, this CMD command will be executed. Java.jar is going to start our application as defined in this Docker file. So let's go back and see how we are going to be able to achieve that. Now, remember, at this stage, we have configured our Jenkins server and we install Docker and added Jenkins to the Docker group. Therefore, if we execute Docker PS, you see that no container is running. Let's do Docker images. No images have been created. So as part of our Jenkins job, we want to create a Docker image with this command, Docker build. So we are going to build this image. See that? We are going to build this image. So let's see how we are going to be able to achieve that. I'll copy all of this. Let me copy this. Copy this. I think I'll just create a new job. Let me create a new job here. Spring App MongoDB. Let me see something. Pipeline job. Okay, our Spring Java application is a pipeline job. So I'll just come here. Now, so it's going to clone the code. You see that it's going to, now, let me just take out this Docker build image for now, or take out this step and introduce this step, you know, later on. Let me take down this step. I'm taking it out. So let me see. It's telling me that something is wrong here. This one opens. It should open and close here. So this should open and close. The next one, source code should open. Git clone. Okay, this is not close. Should close here. Okay. So this opens and close, 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 opens and close. Okay, save. Now let's execute this build now. We are doing a build. It's cloning the code. Okay, so now as part of this build, you realize it has cloned our code from GitHub. It has used Maven to do a build, executed SonarQube quality report, and uploaded the artifacts to Nexus. So now the next thing we want to do, we want to get our Docker images. So we're going to build a Docker image. So what have we achieved so far? Now we have, Jenkins has pulled the code from Docker, from GitHub. Jenkins has executed NVM, clean package, and does a build, executed SonarQube report, code quality report, and have uploaded the artifacts into Nexus. The next thing now is we want to create a Docker image. So Jenkins is going to create a Docker image with a Docker build command. So now, as part of that stage, we have, this stage is Docker build image. So we want to build a Docker image. So we are going to execute the Docker build command for that purpose. So this is the stage. So just copy this. Okay, let me copy this and add it in the Jenkins job. So this is our Jenkins job. Configure pipeline. So now sh docker build-t, so it's going to build this image. Okay, now let's see, let's save, let's apply, save, let's build now. Trying to build the image. Trying to build the image. Oh, we are told that the build is a failure. The build is a failure. Permission is denied. When we are trying to access the Docker run, okay, permission is denied. So let's come back here. So we have permission is denied. You see that? We are told that now when Jenkins is trying to access /var/run/docker sock, permission is denied. So what we are going to do is that to solve this problem, we are going to execute some commands. So in the Jenkins server, we'll do sudo, we'll change ownership, show own, change ownership, show own to Jenkins. okay, /var /run let's show on -arrow. Let's do it recursively. /var /run / that directory is called docker sock. That's a directory, docker sock, enter. Show on. Wait a minute, let me see something. Let me take out the -v option and see what happens. I want to change that ownership. Show on. No such directory. Let me see. Docker. No, I'm the one that made a mistake. It's .sock. So I've changed the ownership of this directory to Jenkins user. Okay, now that it's Jenkins user that owns this directory, let's try to build now again and see if our Docker image will be created. Okay, it's trying to create a Docker image. Let me delete this guy. So delete this upon job. So now our Docker image has been created. So if we execute Docker images, image, we have this Docker image that has been created. Now, the next thing we want to do is we are going to push this image to Docker Hub with the Docker push command. You see that? And for us to execute Docker push command, let me come back here. Let's see what we are going to do. Now, so we have the next stage. The next stage, we want to execute the Docker push command. So we have Docker push or push image. Now we want to push image to registry. This can be Docker Hub, it can be Nexus. Okay, so the Docker image created, we want to push it to a registry. So now, which command do we use to do Docker push? Which command will permit us to push image to a registry? That's sh. Okay, the command, first of all, we have to log into our Docker Hub. So we can do Docker login -u. My username is my landmark tech. That's my username. -password. Maybe I can do password admin 123. Now, with this command, I can log into my Docker Hub account and I'll execute one more command, Docker push, the name of the image. So this is the image that I created. So I'm going to do Docker push, and this image is being committed to Docker Hub. You see that? But now, it is not best practice for me to enter my password like this. It should never be done. So please, never you do that. So how do we get this fixed? I want to refer my password as a variable. You see that? Maybe I want to do something like this as a variable. Let me refer my password as a variable. In that case, I'll do $, referring my password as a variable, maybe password, whatever it is. You see that? I want to refer my password as a variable. So for me to do that, I'll need to create syntax for this. So let's go to our pipeline job. In our pipeline job, I'll go to configure, click on pipeline syntax. In this pipeline syntax, okay, I'll search with credentials, okay, with credentials. So now this is what I want to search here, with credentials, bind credentials to variable. So how do I do this binding? Now, what I'm going to choose here, I'll choose a secret text. So my password, I'll pass it as a secret text. Now, under this information, I'll click on credentials Jenkins. Okay. Secret text. So the secret is my password. Password into my, okay, Docker Hub account. That's the secret. So ID, I can just call it Docker Hub credentials, something like that. Yeah. Docker Hub credentials. So this is my Docker Hub credentials. Here's my password. That's the ID. I click on add. Now the variable, I'm putting there Docker Hub credentials for variable. So Docker Hub credentials, I can now generate pipeline script. So I've generated pipeline script in this order. You see that? I've generated my pipeline script. So I go back here. Now, when I come here, under Docker push, I have something like this. You see that? So this command that is here, I'll copy it up here. Okay, and I'll paste it here. So now, Docker login, that's you, that's my username, -p. Now the password, okay, the value, the variable value for my password, the variable value, this is the variable is Docker Hub credentials. So I'll copy it where I see password, I replace with Docker Hub credentials. So now with this, I should be able, okay, I should be able to log into my Docker Hub account and push the image created. But now, before we do that, let's check my Docker Hub account. I think I have Docker Hub. There's a repository, Spring Boot Mongo. Now, I lastly committed code into this repository 3 hours ago. That is my images. Okay, the last time I committed an image was 3 hours ago. So let me go back to my Jenkins job and try to execute the Jenkins job. We'll see what we are going to be able to achieve. So Docker push. I want to push this. So now the next stage is Docker push. This is the next stage, apply. Everything is okay. Save, build now. Build now. Showing that's created an image. It's logging in. You see that it's trying to push the image. Image have been pushed into Docker Hub. Okay, so we have pushed this image. You see that that is a success. Therefore, if we go to our Docker Hub account now, under this image, let's reload and see what we have. You see that latest a few seconds ago. That's the latest time we push image a few seconds ago, latest version. So now we have this latest version pushed a few seconds ago. So we want to now, okay, deploy this application to our Kubernetes cluster. Now, remember, we were configuring our Kubernetes cluster using kops. You see that? We were configuring the cluster using kops, and we were told to wait for 10 minutes. So let's check this cluster if it is okay or no. Let's check our cluster. Now, if we do kubectl, or let's do kops get cluster first, kops validate. Okay, we're giving some commands to run. Kops validate cluster. What do we have? Our cluster is running. It has 3 nodes. There's a master node, okay, and there are 2 workers. we can log into this master node. You see that? We can log into our master node. Very possible. And for us to log to the master node, we have been given an option, SSH-I. Okay, with this option, we can connect to the master node. That's what we have been given. So what I'm going to do here is, let me duplicate this session and try to connect to my master node. So I'm duplicating this session. But even if I don't connect to my master node, since I have kubectl running in, okay, I have kubectl in my Jenkins server. So if I do kubectl get all, you see that? I can talk to the API server. So I'm able to use my Jenkins server and communicate with my API server in this Kubernetes cluster and make API calls. You see that? kubectl get all. I can communicate with this cluster. Therefore, now what has happened? Developers have committed code into GitHub. Jenkins has pulled the code. Marvin has done a build, NVM clean package. Now, SonarQube have executed code quality report. Once that report was fine, we uploaded the artifacts into Nexus. And now we use Docker to create an image. This artifact, we package it into a Docker image, and we have pushed that image into Docker Hub. Therefore, in the Kubernetes cluster, when we are trying to do it, okay, now, if we deploy this application, we can now deploy our application as Docker containers in this cluster. Kubernetes will do what? Will manage the cluster and the Docker containers for us. But for us to achieve this end-to-end process, okay, we are going to add one more stage. Let's add one more stage in our pipeline job. And this stage, okay, this stage, we are going to call this stage deploy. We call it deploy, okay, deploy to Kubernetes. Kubernetes K8s. So we want to deploy application to Kubernetes. Now, for us to achieve that deployment, what do? kubectl. We are going to use kubectl apply. But before we do that, there must be sh in front. kubectl apply -f. Now, let's go back to our project file. In the project file, we have, okay, this is our Kubernetes manifest file. In this Kubernetes manifest file, we are deploying, okay, a Java web application built on the Spring Boot framework. So we have here Spring App deployment. We are deploying this application. We want to deploy 2 replicas of the application. You see that? And in the deployment, we need a MongoDB database. So we are referring some environmental variables. Now, we are equally deploying, we are creating a service of type load balancer for our application. And now it is easy for us to create a service of type load balancer because we had configured a Kubernetes cluster using kops. So when we choose load balancer, okay, now it is going to create for us a network load balancer in our AWS account. So that is the advantage of using kops. So now, what else are we deploying? Okay, we are creating this service. We are equally creating a persistent volume claim because when we install our cluster using kops, it comes with persistent volume. Therefore, if we do kubectl get PV, okay, no resource, but let's do get storage class, SC. Now, we have, okay, now storage class has been provisioned. You see that of Elastic Block Store, AWS Elastic Block Store. Since we have this storage class, when we create PVC, it is going to create PV for us as well because we already have a storage class configured. So we are creating persistent volume claim for our MongoDB database. And we are deploying the MongoDB database as a replica set. That's what we are doing. You see that? And we are equally deploying service of type cluster IP for our MongoDB database. But all of these tasks is going to be automated. You see that? Will be automated. So let's see how we can connect to our, okay, let's connect to our Kubernetes cluster. This is the command that we need to connect to that cluster. Let's connect to the cluster. I've duplicated my session so I can, use the other session to try to connect to this cluster. How many sessions do I have? Let me click here, duplicate. So I'm duplicating this session. So I want to connect to my cluster. Kubernetes cluster. So clear the screen. So sudo su, let me become Jenkins again, the same server. So now if I execute this command, let me try to connect to my cluster. Executing this command. Execute this command. Now, SSH-I want to connect to my cluster. Enter. Host name cannot be resolved. Let me change this. Let me change this guy to admin. Let's see what I get. Admin. Host name can't be resolved. So let me check the cluster that was configured in AWS. We have now, this is our cluster that was configured. We have a master and 2 worker nodes. So let me try to connect to this cluster. Connect. SSH client. So this is what I get here for SSH client. It gives me this long command. Let me see. What do I have here? Oh, SSH-I EC2 user. I think this is what I got here. EC2 user. So come back and minimize this guy. SSH-I, where I have the API. API admin at, okay, enter. Yes, I want to connect to my cluster. Permission denied. Why did I have permission denied? Let me see something again. It was admin that I'm supposed to use to get into this cluster. Let me try Ubuntu. Okay, so now I am in my cluster. So this is my cluster, kubectl get all. Can you see? This is my cluster. This is my Jenkins server. This is my cluster. So what we are going to do next is that let's go back to our Jenkins job. So in a Jenkins server, we have created some images. So if we execute Docker images, we have some images created. So we don't need these images because it will just consume our hard disks and our server can begin to run slow. So what we are going to do is that after we have created this image and pushed to Docker Hub, okay, we are going to add one more stage to delete those images. But now, remember that we have the stage to deploy to Kubernetes cluster. And how do we achieve that deployment? Okay, now this is our manifest file, springapp.yaml. So springapp.yaml. So springapp.yaml, kubectl apply, springapp.yaml. Now, before this stage, okay, we are going to do one more thing. We'll add one more stage in front of this guy. And in this stage, we are going to remove images. Let's remove, okay, Docker images. We are removing Docker images in this stage. So now, sorry, using the curly bracket here. So which command can we use to remove Docker images from our Jenkins server? Which command? sh. The command is called docker remove image. Okay, docker remove image $. Docker remove image. We want to remove all the images $. Okay, docker images -cure. So this command is used to delete images. So what we'll do is that we'll first of all execute this step. You can see that we have images there. Let's execute this step without doing any, okay. Anyway, let's just execute both steps. We'll remove the images because we don't need them anymore in our Jenkins server, since Kubernetes will pull the image from Docker Hub. You see that? So let me copy these two stages. Let's add it to our pipeline script in Jenkins server, pipeline script. So configure pipeline. Now, pipeline script, enter, kubectl apply -f. Let me see something there. kubectl apply -f, docker remove images, save. Now, let's execute this command now, build now. Let's see what happens. Remember, in is doing a build. Now, if we do kubectl get all, at the moment, we don't have any application running here. kubectl get all. Let's execute here Docker images. Can you see it has passed that state? It has deleted all the Docker images. So Kubernetes, can you see? Is trying to deploy to Kubernetes. That process also has been done. Therefore, okay, what have we been able to achieve? Now, we have been able to achieve this entire circle that we saw here. We have been able to achieve this such that, you know, our application has now been deployed. So I can I can access my Kubernetes cluster either from my Jenkins server or from the master server. So let me try to access it from the Jenkins server, kubectl. Let me do kubectl. kubectl get all. Can you see our applications are running? You see that? You see, look at something, kubectl get all. So I'm able to access my Jenkins, okay, my Kubernetes cluster for my Jenkins server. Reason being that in the Jenkins server, I had installed kubectl and I configured my corpse as Jenkins user. Okay, so we have deployed this application. This application has been deployed with a load balancer. This is the load balancer. So in AWS, this load balancer has been created. So now, in trying to access this application, okay, I'll just enter the URL of my load balancer. What do I get? Can you see? This is my application. I'm able to talk to this application. You see that? This is the application that we have here. Okay, this is the application. Now, it's a Spring Boot web application, which implies the application has been developed by our developers using a Java framework called Spring Boot. It is a Java application. It needs a MongoDB database. You see that, and we have used Jenkins, Docker, and Kubernetes for this project. Therefore, let's try to see if we can enter information into our database. Yes, we can. Okay, so we have achieved full automation. And as we saw here, when end users are trying to access this application, okay, the application got 3 different tiers. Okay, we have the load balancer tier, where end users talk to the load balancer. The load balancer now route the traffic to the application, and the application talks to the database. So those are the different tiers that we have for this application. You see that? But now, there is one more thing we are going to do. We are going to configure, okay, we are going to configure host name details. You see that? Using DNS. So we use DNS, domain name service. So I've already bought a domain name service from AWS. So I'm going to use that to define some A record. You see that? So let's see how we can achieve that. In my AWS account, I'm going to search for Route 53 service, Route 53. Now, I'll go to DNS management, domain name management. Now I have app23.com. I click on it. And I'm going to create, okay, a hosted zone. You see that? Or I can, okay, edit one of my A records. So let me create a new record. Let me just create new record. I'm going to call this app. Okay. Let me call it Spring Java app. Spring, okay. Spring Java. You see that? Or let me just say Spring Boot. So I'm creating a record, springboot.myapp23.com. It's going to be an alias to an application and classic load balancer. Application and classic load balancer is in US West 2, Oregon. Now in US West 2, I have this load balancer which have been created. This is the load balancer here. So US West 2, I'm creating a record. So this A record has been created. You see that we have created this A record, okay? And the A record, as we saw already, therefore, if we want to access our application, we can use the A record that we just configured. So let's see how we can use the A record to access our application. This is the A record. Therefore, in accessing the application, this is what we are doing. You see that? This is what we are doing. We have something like this. Now, when end users, okay, we have set a record in this order. This is our A record. Therefore, when end users want to talk to this load balancer, they are using the Route 53 service. You see that? We have added one more service here, which is Route 53, AWS Route 53. Now, in this Route 53 service, we have defined a record such that rather than end user, because as we saw here, this load balancer URL or DNS name is too long. Therefore, when end users wants to talk to our load, okay, wants to talk to this load balancer, you see that when they are trying to talk to this load balancer, this is the load balancer here, okay, very long, DNS information. So when they are trying to talk to this load balancer, they will talk instead to our, okay, they will use the host name, okay, based on the A record that we have defined. So this host name is pointing, okay, to this load balancer. Is pointing to this load balancer. You see that? So now, in that case, end users, all they will have to type will be something like this. They'll type this information. Now, once they type this information, what do we have? Okay, they are typing springapp.myapp23.com. It takes them into our application. Please, this is what we call multi-tier deployment. And it is very important for a DevOps engineer to have a good understanding. Now, let's go back to our Jenkins job. This is our Jenkins job. In this Jenkins job, let's configure some automation. We'll come here to build trigger. Let's configure pool SCM. So in the pool SCM, okay, let's do every minute. So every minute, what will happen is that, what will happen is Jenkins will go to our GitHub repository and check if there are any changes in the code. Jenkins is going to trigger a build. So now this is how our application is. As you can see, we can access this application using the load balancer URL or using our domain name. So the domain name is better because it is easier for end users to have a name like myapp.com than to get some long alphanumeric, okay, information like the one we have here. But now we have configured, okay, pool SCM. So let's see how we can use this pool SCM. So I'll go back to our project in GitHub. This is the project in GitHub. So in this project in GitHub, we have our source code. Let me modify something in the source code. Let's see what we get there. Resources, I have images. Okay, I have logo. Okay, I'll just change the logo. Let me see if I can change the logo. Let me see something. Let me change this logo. Okay, I want to change the logo. Let me see. One step behind. Images, logo 1. Okay, I'll change this logo to logo 1. Okay, .png. So let me change the logo. So it's like developers are trying to modify the code. They want to change this logo. So let's see how it's going to change in our application. So I'm just changing an information. Remember, I've configured pool SCM. Okay, so now that I've changed that logo, I'll come here to my code, resources, go to template. I'm checking for the index.html file. Now, I'll just change the logo name. Let me see the logo name for the line where the logo information is defined. Okay, this is the logo. Let me delete this. I'll change the height to 200. Change this logo information. That's changed. Logo 1.png. Image as well. Logo 1.png. Let me commit the changes. Now I've committed these changes. Once I commit these changes, very soon Jenkins is going to trigger a bill because I've automated the process. You see that? So Jenkins is going to trigger a bill very soon. The project is automated. We will not trigger a bill manually. Let's see what Jenkins will do. Jenkins will trigger a bill. So we have configured pool SCM. Every minute, Jenkins will check our repository, okay, our project repository. If there are any changes, Jenkins will trigger a bill. Can you see? Jenkins is okay. Can you see that? It has cloned the changes. It's just like, because developers have written a new version of the code, it will clone the changes. It will execute Maven clean package goal. It will execute SonarQube quality report. It will upload artifacts to Nexus. It's going to create a new image. It will push the new image, okay, to our registry, like Docker Hub, for example, and it will remove the image from our build saver, and it has deployed to Kubernetes cluster. So all of this is taking place. So this is how you can achieve full automation in your project. So if you want to achieve full automation in your project, this is how that can be achieved. So let's do kubectl get all. You see that? Now you realize that, okay, kubectl get all, I think it's doing the deployment. Now, replica set MongoDB. Let's check if now it has done the second deployment. So everything has been done. kubectl get all. Let me clear the screen. kubectl get all. So the new version of our code has been deployed. You see that? The new version of the code has been deployed. So I can either access it. Let me try to access it from here, myapp.com. New version of our code has been deployed. So I can add more data and submit. You see that? So please, this is how we can achieve full automation. So With one click, this entire process is being executed for us with one click. You see that? This is Jenkins, Docker, Kubernetes integration. So please take note. You could also call this a tier 3, okay, or multi-tier web application. So take note again, if this has been a video from Landmark, is that okay? So if you need to know more as far as DevOps processes is concerned, please don't hesitate. You can contact us at Landmark or just go through our YouTube channel. Okay, you are going to be able to have, good videos to help you in your projects, be it at work, okay, or if you want to start up a career to become a DevOps engineer as well. Okay, these are some of the projects that you need to be able to have a good understanding on, explain them vividly and with maximum ease. So this has been what we call a multi-tier application, and we have deployed it using Kubernetes cluster that we configured using kops. So this is a production grade Kubernetes cluster. And as you saw, whenever developers commit a new version of the code or changing the code to GitHub, okay, or our source code management, Jenkins, we're going to pull the changes. Jenkins will integrate with SonarQube, okay, Maven to do a build, SonarQube for code quality, Nexus to upload the artifacts, and Jenkins is going to build a Docker image. Therefore, Jenkins is also our build saver. It builds the Docker image and push to GitHub. And we have to clean the Jenkins server by deleting the Docker image from the Jenkins server since it is already in Docker Hub. When we are trying to do a deployment in our Kubernetes cluster, what happens? Once you execute kubectl apply, Kubernetes is going to pull the image from Docker Hub, and end users can access the application using our host name configured using DNS services of AWS called Route 53. So please, thanks so much again for joining me in this presentation. Take note as well, you can equally subscribe to our YouTube channel. Okay, for more videos, you can subscribe to our YouTube channel for more videos. We have a good number of videos that you can always go through, and you can subscribe to this YouTube channel for more videos on DevOps. So thank you so much. Have a great day.